Hey everybody, we're gonna take some very brief notes on section 8, but really what we're going to be working through is a few examples for your practice exercises, and in this ed puzzle we will also be doing a few of the problems in your homework. Okay, so go ahead and turn to section 8 in your note-taking guide and let's get started. So in this lesson you've already learned how to use trig functions to model and solve real-life problems. And that's what we're going to be doing today. So in this example number 1, we're giving a word problem and we're going to make a visual or draw it out and see how we can use trigonometry to solve. So here we go. A ladder leaning against a house reaches 24 feet. So let's draw that. So here's the house. Okay, it's a very small house. Here's the ground. And here's the ladder. Okay, so there's the ladder. And it says it reaches 24 feet up the side of the house. So where is 24 feet? And it's up the side of the house. So we say this is 24 feet. The ladder makes a 60-degree angle with the ground. So here's the ground and here's the ladder. So this angle is 60 degrees. It says how far is the base of the ladder from the house. So here's the base of the ladder and here's the house. We're looking for how far is this? Round your answer to 2 decimal places. So I'm just going, since I've already gotten my drawing there, I'm going to bring this over and have a more simplified version of that visual. So this is 60 degrees and this is 24. So I want to know, how can I solve for x? So remember, if I have this right triangle and I can label each side, so I know opposite of the angle is the opposite side. Here's the hypotenuse side and here is the adjacent side. So I know adjacent and opposite. I'm looking for the adjacent side and I've got the opposite side. So using SOHCAHTOA, I know that tangent is the function, the trigonometric function that works with opposite and adjacent. So I can say the tangent of the angle, which is 60, equals opposite over adjacent. And now we're going to solve for x. So solving for x means I'm going to need to multiply by x to both sides. And then we've got x times the tangent of 60 equals 24. And now we're going to divide by the value of tangent 60 to both sides. And this will cancel, and we end up with x equals approximately, put it in your calculator, round it to the nearest second decimal place, 13.86 feet. Okay, and then there's 2 very, very similar to that in your homework on numbers 19 and 21 in your practice problems. Okay, and now we're going to talk about trigonometry and bearings. So here's what that means. Trigonometry and bearings, these are used to give directions in surveying and navigation. A bearing measures the acute angle that a path or a line of sight makes with a fixed north or south line. Okay, so keep in mind, just like this compass here, remember this, learning this in like elementary, remember never eat shredded wheat or never eat soggy waffles. We use that as our compass, and it's always in reference to the north-south line. So here, the bearing means north 70 degrees east means this. We're going to start, let me interpret this first. So we say this is really 70 degrees east of the north. Okay, so north means it's a reference line, either the north or the south is your reference line. It gives you an angle and in which direction to go from. So if I were gonna graph north 70 degrees east, the way I would do that, I'm going to put it right here. If this is north, we're starting here, and then I need to find the east direction. So I know this is the east direction, so I'm going to go 70 degrees towards the east. And that this line right here is north 70 east. So for example number 2, it says write the bearing for the path shown in the diagram. So what we see here is this is the line that we're looking for. So which one is it closer to, north or south? Hopefully you're seeing south. So we're going to start with south, okay? And then we're going towards the west direction. So from the south, how many degrees are we going? Well, we could say this, if this is 30, I know this whole angle here is 90, which means from here to here is 60. So we could say south, 60 degrees west. And that means we start at the south and we go 60 degrees towards the west, and that's going to give us our location. Okay? So you should be able to go from a bearing and graph it, or from a graph and name the bearing. Okay, we're not going to go over harmonic motion, but I do want to go over something that we were going to do in section 7, but we're officially skipping section 7. We're not going to go into it in much detail, but I wanted to give this to you. This should be a review, but we're going to talk about opposite operations. So put this on the side, in that right side of your notes that you have open. And we know that addition and subtraction are opposite operations. We know that multiplication and division are also opposite operations. We know that radicals and exponents are also opposite operations. So like if something has a square root of 2, its opposite exponent is 2, right? Those are opposites of each other. So when it comes to trigonometry, here's what we have. Oops. We have the operation of sine is to take the ratio of an angle, but the opposite operation of that is what we call inverse sine. So we would normally say sine finds the ratio, and inverse sine finds the angle. So these are opposites of each other. The other one that's an opposite, you might already guess this, is that the opposite of the operation of cosine, which finds the ratio of an angle, is the inverse cosine, which tells you which finds the angle for you. So again, when we're using these, cosine finds the ratio, inverse cosine finds the angle. And lastly, tangent has an opposite operation of inverse tangent. And tangent is going to find the ratio of the angle, and inverse tangent is going to find the angle. Okay, so these are the 3 things that we're learning that are new. So if we're trying to solve for, let's say, an x, where we're talking about sine x, we would use the opposite operation to get x by itself. And we're going to talk about that when we start our practice problems, which is going to start right now. So if we go ahead and go to some exercises for section 8, this is part of your assignment. So this is going to be in your notes, but it's also part of your assignment. So if you want to just go ahead and add this to, or start your assignment for section 4.8, this is great. Number 5 is your first one. And it gives us this, if you want to pause here and set up your paper, that's fine. It gives us this figure, and they say use this figure for the problems for numbers 5 through 14. So here's our figure, and this is what it gives us. That angle A is 30 degrees, so that's right here, and side B is 10. It wants us to solve the triangle, and here's what that means. We need to find angle, we already have angle A, so we're looking for angle B and C. And we're also looking for side A, We know side B, and we're looking for side C. So here's what we're going to do. We've got this angle and this side. So from this angle, I'm going to label the rest of everything that we have. So here's our opposite side, our hypotenuse side, and this is our adjacent side. We also know angle C is this 90-degree right angle. So we're going to fill that in right here. What we also know about that, if I know 2 out of the 3 angles, I know an entire triangle equals 180 degrees. So that means I know 30 degrees, which is angle A, plus 90 degrees is angle C, plus angle B is going to give me 180 degrees. So just like in geometry, I'm going to solve for angle B. If I subtract 120 degrees from all of this, we get angle B equals 60 degrees. Okay, so the easy stuff is out of the way. Now we're going to find our 2 sides. And you might have guessed it, we're going to use our trig functions, or SO, CA, TOA, to find the other 2 sides. So it doesn't matter which one you find first. Let's just go ahead and decide we're going to use A. So I know if I'm looking for the opposite side and I'm given the adjacent side, I can say, well, the trig function that we can use for this is tangent. So we know tangent of the angle, which is 30, equals the opposite side, which is A, we don't know it, over the adjacent side of B, which is 10. And now let's solve for A. We're going to multiply by 10 to both sides, and we get A equals the 10 times the tangent of 30. So we end up with a value of, let me get my calculator out. We're going to go 10 tangent. Oh, and don't forget that your mode needs to be in degrees in your calculator because we're dealing with degrees. So if I say 10 times the tangent of 30 degrees, we know A is 5.77, and that's rounding to the nearest hundredth. So you have 2 choices. You can either continue to use trig functions now, or you could, because we've got 2 of 3 sides of a right triangle, you can use Pythagorean theorem. Because this is being rounded to the nearest 2 decimal places, I'm going to go ahead and use my trig function still to find the value of C. Okay, I know that A is 5.77, but it's rounded, and I don't really want to use it. So I'm going to use what I know about the adjacent side is 10, and I'm looking for side C. So what deals with adjacent and hypotenuse? Well, that's this trig function right here for cosine. So we know cosine of the angle, which is 30, equals the adjacent, which is 10, over the hypotenuse, which is C. I'm looking for C. So I don't want it in the denominator. I'm going to multiply it out, which means right now I've got C times the cosine of 30 equals 10. Divide both sides by the cosine of 30. And we get C equals 10 divided by the cosine of 30, and make sure that your mode is in degrees. And we get 11.55, and again, that's rounded. And you're done. I hope that makes sense. I hope that looks familiar to you from geometry maybe, okay? So that was if you're given the angle. Number 7 from your homework you're going to do on your own, very, very similar to number 5. Let's go ahead and do number 9. So number 9 is using the same figure, but instead of giving us an angle, they've given us 2 sides. So let's go ahead and label this, okay? So A is 6 and B is 12, and we don't know the other pieces of the triangle. So we're looking for side C, we're looking for angle A, and we're looking for angle B. We know that angle C is 90 degrees. So what we're going to do first is 2 things. If I know 2 of the sides of the triangle and they're perfect, they're not rounded, I'm going to use Pythagorean theorem to solve the 3rd side. So I know A squared plus B squared equals C squared, where C is the hypotenuse. So let's plug this in. So I know 6 squared plus 12 squared are the legs. They can go in either place, equals C squared. So I know 6 squared plus 12 squared is 180 equals C squared. To get C by itself, I take the square root. And the square root of 180 is, it's really ugly. It's like 13.41, blah, 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 blah. So what I'm going to do, because I don't want to have to round it right now yet. Okay, in my answer, I can put 13.41, but I don't want to round it. So I'm going to give it the perfect root of 180 so that it's exact. Because when I'm looking for the angles, I'm going to need that perfect side, or maybe not. I don't know. We'll see. If we're looking for angle A, let's mark it off right here. I don't know what it is. Here's looking from here. Let's label what we've got. This is the opposite side. Here's the hypotenuse side, like we said, and here's the adjacent side. What's nice about this is I've got 3 sides to choose from. So I'm going to pick the 2 sides that are perfect, not rounded, 6 and 8. Or excuse me, adjacent. So the opposite and the adjacent. So I know tangent of the angle, which I don't know, what we're calling it angle A, is the opposite over the adjacent. So here's the thing. I want to solve for A, but right now, do you see how there's this tangent attached to it? Remember how we just learned what's the opposite operation of tangent? Well, we learned that it's the inverse tangent. So these are going to cancel each other out, which means I need to take the inverse tangent of both sides. So this inverse tangent will cancel out this tangent. So I get angle A equals the inverse tangent of 6 divided by 12. So if you use your calculator, you'll see, you'll hit the second key, tangent, and you'll see that little notation of inverse tangent. And then we're going to put in the parentheses 6 over 12. And we get that angle A is approximately 26.6 degrees, and that's rounded. What's nice about this is now I know 2 out of the 3 angles. So if I know angle A is 26.6 degrees, I can find the other 1 angle. So I'm going to erase this a little bit. Sorry, I messed it up. Here's 26.6 degrees. So if I know this is 90, I can subtract those from 180 and find angle B. So I know angle B equals 180 minus 90 plus 26.6 degrees. Because 180 is the entire triangle. And so we end up, this is 116.6. So we get, and if I subtract 180 minus 116.6, we get 63.4, approximately, for angle B. So the hardest part was finding that first angle where we had to use our inverse, or opposite operation of tangent, which is inverse tangent. Okay, so hopefully that makes sense to you. You're going to go ahead and do number 11 in your homework. And then the next one we're going to do together is number 15 from your homework so that you can do the rest on your own. So we're given this figure. It's an isosceles triangle. Both of these base angles are congruent, and they're giving you this base of B. So they're telling us that theta is 52 degrees. So this is 52, and this is 52, and this is 8. It says find the altitude, which altitude is, remember, from the vertex down to exactly half of the base. So if I split up the base into 2 equal parts, because it's an isosceles triangle, I know this would be 4 and 4. So really what I'm going to do is I'm just going to look at this part of the triangle. So I know this is 52, this is 4, and I'm looking for the altitude, so I'll call this side A. So here we go. We're going to label this from here. This is the opposite side. Here's the adjacent side, and we're given the angle. So let's set this up. If I've got opposite and adjacent, I know, looking at SOHCAHTOA, I'm going to use tangent of the angle equals the opposite side over the adjacent side. We're going to solve for A. Multiply both sides by 4, and we get A equals 4 times the tangent of 52. Make sure your mode is in degrees. And we get 5.1, and that's rounded. So that's our altitude. Okay, so that was number 15. Now you're set up to do number 17, and then the rest is just like the example we did in your notes, and I'll see you in